Assalamu alaikum, everybody here. You can hear me? My voice is clear? Okay, thank you. طيب إن شاء الله today we are going to revise على ال polymerization و how to make polymer and the hydrolysis of the esters. Okay? And we have some equations كده with some definitions we need to revise on. As you know that the past paper is important. Don't leave the past paper from your hand. And at the same time, you need to collect the curriculum. محتاج كده to collect the curriculum. In all cases, I will send you another summary, like all definitions and all equations, everything. بس أنا محتاجة أشوف الأول your own work. Clear? طيب يلا بينا هنبدأ على بركة الله. بسم الله. اللهم إني أسألك فهم النبيين وحفظ المرسلين والملائكة المقربين. اللهم اجعل ألسنتنا عامرة بذكرك وقلوبنا بخشيتك وأسرارنا بطاعتك إنك على ما تشاء قدير. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي. يا رب لا سهل إلا ما جعلته سهلا وأنت إن شئت تجعل الصعب سهلا. صلى الله على سيدنا محمد صلى الله عليه وسلم. اللهم افتح علينا فتوح العارفين. يا رب افتح علينا فتوح العارفين. اللهم افتح علينا فتوح العارفين. اللهم يا معلم إبراهيم علمنا ويا مفهم سليمان فهمنا. صلى الله على سيدنا محمد صلى الله عليه وسلم. شوف يا رجالة، في ال IGCSE curriculum you have a part of polymerization. Okay? So the polymerization according to the IGCSE has two types. Bismillah. The first type is addition polymerization. This is addition polymerization. And the second type is condensation polymerization. Condensation polymerization. Okay? Guys, you can see my screen? I hope that is my screen clear. My screen is clear. Okay. يبقى احنا كده we have two types of polymerization. I hope that you are writing with me. Addition polymerization and the condensation polymerization. Done? طيب regarding to the types of polymerization, we need to know that إنه addition polymerization, this is the process or the chemical reaction in which you can join up the alkenes together. فالaddition polymerization it just specified for the alkenes. وما دام قلت alkenes يبقى I'm talking about C double bond C structure. C double bond C structures, okay? In this C double bond C structures يبقى you have alkene. You will break down the double bond and only one product is formed. Only one product is formed. Okay? طيب what about بقى the condensation polymerization? In condensation polymerization, the polymer formed by taking away or eliminate the water. So here you have two monomers joined together, okay, and water is eliminated. The water is eliminated. Clear? يبقى in the addition polymerization we have monomers called alkene. But in the condensation polymerization, we have two different monomers and each one has its own functional group to remove the water. Now let me define to you the monomer and the polymer. What's a monomer? Monomer. What's a monomer? Monomer is a small molecule which can be polymerized and joined together to make polymer. تاني, small molecule which can join together to form polymer. This is the monomer. طيب what's a polymer? What's a polymer? The polymer is the large molecule. Polymer is large molecule, macromolecule, okay, which is formed from the combination of the small monomers together, where we need high temperature and high pressure and the catalyst. تاني, macromolecule, حاضر. Macromolecule formed from combination of small units اللي هي المونومرز يعني under the effect of high pressure, high temperature, and the catalyst. Okay, so this is a definition of polymer and monomer. I hope that is clear. Okay, let's continue. So now we know what is the polymer. What is polymerization? This is a chemical reaction in which the small monomers join together to give you a polymer. We have two types of polymerization. The two types of polymerization are addition polymerization and condensation polymerization. Okay? The addition polymerization is specified for alkenes only. So only alkenes can make addition polymer. And only one product is formed. That's why this is an addition reaction. But the condensation polymerization, we have two monomers. When they join together, water is removed or eliminated. The word eliminated means water is removed. I hope that is clear. Monomer is the small molecule which join together to give you the polymer. So if this is the monomer, so monomers which are very small join together by a chemical bond to give you the polymer. So those are monomers. And the large structure, this one is polymer. Is that clear? I hope that's clear. طيب كده بقى let's move to see how the addition polymer is formed. So number one, I will talk about the addition polymerization. I hope that you are writing with me. لأنه if you didn't write, you will forget. So please write with me. Addition polymerization. In the addition polymerization, we have alkene. So show me which alkene can polymerize. Any alkene can polymerize. This is the ethene. Ethene has double bond. If we have any unit from ethene, they will polymerize to give me a polyethene. What you are required to do is to break the bond. You will break the bond like this. You need to break the bond. Then breaking the bond will give you a single bond. And take the structure, copy paste. Take the structure, copy paste here. And then bond at the left and the bond at the right. And the square bracket like this one, big square bracket and the end. Now you have N unit joined together. So the product will be in unit inside this bracket. And if this is ethene, so the product will be polyethene. Is that clear? So if you are required to draw the polyethene, you will open the bond at the left and the bond at the right, and the big bracket like this in the square form and write N. So this is polyethene. Actually, the questions comes like this. Draw three repeated units of polyethene. Now, if you are going to write the repeated units, you will not add the bracket and you will not add the N. Yani all what you need to do is to take the structure, copy paste without the double bond. And this is one unit. It has a bond at the left and the bond at the right. And this is another unit here, like this. And this is the third unit, like this. So here we have three repeated units. Check here with me again. This is one unit here. Okay, and this is one unit. And this is one more unit. حاضر. Okay. Guys, you can see this. This is unit 1. unit 2, unit 3. يبقى what we are doing now is just drawing the repeated unit. Okay? يبقى repeated unit doesn't have bracket, doesn't have n. All what you need is to draw the structure like this. Let me draw one more example. Let me draw one more one. See, I need to draw the propene. By the way, propene is a strong polymer used in making plastic bottles. See, propene, prop, يعني 3 carbons. 1, 2, 3. CH3, hydrogen, hydrogen, hydrogen. This is propene. To polymerize the propene, take it, copy paste, 1, 2, CH3, and hydrogen, and another hydrogen, and the hydrogen here, bond at the left, and the bond at the right, and the square bracket, and the N. This is the polypropene. Okay, so all what you need is to take structure without the double bond. Two things which are important here. Usually when we take any unit from the alkene, like propene, which is short chain alkene, it's a gas. And when we polymerize, it's changed into solid. So this process is called solidification. You change a gas into a solid in one step. This is called solidification. The polymer is a large molecule. So the polymer is a large molecule. It's a macromolecule. In the exam of November 2025, you have asked to draw, you are asked to give me a reason why we can't give the certain formula for the polymer, the certain molecular formula. So let me put here this observation. The molecular formula of the polymer cannot be identified because there is not definite number of carbon and hydrogen. Here, this is N. So this is a long chain, and we cannot identify the molecular formula of the polymer by this way because it has non-definite number of carbon and hydrogen. Okay? يبقى the molecular formula of the polymer cannot be identified. Due to the indefinite number of atoms. We can identify the molecular formula if he remove this N and put a definite number. If he said 3, 4, 5, 6, 7, inshallah, حتى 100, 1,000, 1 million, so we can identify. Okay? Then let me move with you to a structure here. Type number 2, condensation polymerization. In the condensation polymerization, we have two types of polymers. Number 1, polyamide. Polyamide. Number 2, poly means many. Polyester. Polyester. What is the shape of the amide linkage? Amide linkage is C double bond O N bonded H. This is the amide linkage. So C double bond O N H. This is the amide linkage. And we can see this amide linkage in two types of polymers. One of them is natural, which is protein. And the second one is artificial or synthetic, which is nylon. Clear? Then back again to the polyester. They are polyester because they have ester linkage. This is the shape of the ester linkage. COO. Ester linkage. We call it what? Ester linkage. We can see this ester linkage in two types of polymers. One of them is synthetic and one of them is natural. The natural polyester, the natural one is fat or fats. The synthetic one is terylene or PET. We have a lot like terylene or PET, a lot of polymers which are polyester. Now, what you are going to do now is to write one equation for each polymer. So this is 1, 2, 3, 4. Let's start with number 1, protein. Now, we said that protein is a polymer. So number 1, protein is a polymer. Polyamide. It has amide linkage. C double bond O, NH. So what is the monomer forming protein? Monomer forming protein. المونومر forming protein is amino acid. What is the shape of the amino acid? Amino acid is written like this. If we have a structure here containing carbon and hydrogen, we don't need to know how many carbon and how many hydrogen. We do that this is amino acid, so this is carboxylic group, C double bond O, OH, and this part is responsible for acidic property. This is carboxylic group and amino group, NH. Okay? So I can imagine that, this is the formula of the amino acid. In 2025, we have one more question about general formula of amino acid or general displayed formula for any amino acid. C, instead of the box, C, R, and the hydrogen. And we have here C double bond O, OH. And here we have N bonded the hydrogen and the hydrogen. So this is the displayed formula for any amino acid. Okay? Now we have two methods for writing the formation of protein. Either by the way of writing the box by this way, or writing C and R. I will write both. Okay? The first way, I have amino acid number 1 here, which has two functional groups, carboxylic and amino group, will react with amino acid number 2, which has two functional groups, carboxylic and amino. They will react together, and the product will be water. Remember, we said we need to remove the water. One hydrogen will be taken from the amino group, and the hydroxyl group will be taken from the carboxylic group. Then I will take away the water from the two monomers together and remove, and I will not rewrite again. And because you remove the hydrogen from the amino group, you need to remove one hydrogen again from here, as if there is another amino acid will react from this side. And because you remove the hydroxyl group from the carboxylic, you need to remove this another hydroxyl, as if there is another amino acid will come and react from this side. There is NH2 will come and react from this side. All the parts which are in green will be removed. Rewrite the structure again without the green parts. So I have here A1, and this is NH, and this one is left open. Then C double bond O. Then jump the road to have this NH. Now skip the water, NH. Then you have another box. Then A2. Then C double bond O. Then it will be by this way. This is protein. It's a natural polymer. Now check with me something very important to identify if this is a natural polymer or not. You have amino acid 2 and you have amino acid 1, right? You have to check the bond around these boxes, left and right. Here, C double bond O, and here we have NH. focus about this part because I will come and ask you again about this part. يبقى كده you have C double bond O at the left and you have NHA at the right. طيب consist, if you want to write this equation again, but instead of using the box, you will use the general formula of amino acid. Imagine that the simplest amino acid in chemistry will be like this. This is C, and you have hydrogen above and the hydrogen down, or R above and the hydrogen down, or R down and the hydrogen above. It will not make difference for me. And you have C double bond O, OH. And here you have amino group, and those will react together. C, hydrogen and the hydrogen. C double bond O, OH, NH2, amino group. Start to remove the water. Take hydrogen from the amino and take OH from the carboxylic. Remove this part. This is the water. I need to make it with the blue. This is the water. I will remove all of this water. Okay? And you will remove OH from this side, and you will remove the hydrogen from this side. Rewrite the structure again. Rewrite the structure again. حاضر. I will rewrite the structure again. Just write with me يا تيام انت ويوسف وبعدين I will receive your questions. When you rewrite the structure, all what you need is to repeat writing the two monomers joined together but take away the water. So I will start writing from here. The first amino acid, C, bonded to hydrogen and the hydrogen up and down. Then at the left and the right, one of them, C double bond O, and the second one is NH. This is the first part of the monomer. Then continue writing. Skip this water away. We will take away the water minus H2O. And then jump the road to find the NH. So NH here. Then again, C, hydrogen, hydrogen, C double bond O, open. I will not write this part. I will not write this part. I will not write this part. But what is this, Yamis? This is protein. How do you know that this is protein? From the amide linkage. Where is the amide linkage? This is amide linkage. This is the amide linkage. Amide linkage is C double bond ONH. I hope that is clear. By this way, we end the first part, which is protein, and we have to move to the nylon. Nylon is a synthetic polymer. So I will make a line here. And nylon is a synthetic polymer. Write with me number 2, nylon. Nylon is a synthetic polymer. Synthetic polymer has amide linkage, يبقى C double bond O NH. Okay? Then draw with me. What is the monomer forming nylon? Nylon has two different monomers. Not like protein has only one monomer, which is amino acid. لا, two different monomers. Diamino and dicarboxylic. Diamino and dicarboxylic. Let's draw and let's study together now. Yalla, let's memorize with me. You have a box having here diamino. Di means 2. So we have here hydrogen and the hydrogen, and here we have hydrogen and the hydrogen. This is the first monomer, which is diamino. Yes, we have two amino group, NH2 and NH2. Then we have another monomer, which is dicarboxylic. Let's draw together. This is the first part. Here the box. Dicarboxylic, يعني two carboxylic groups. So we have here OH and here C double bond O, OH. Now all what we need is to remove the water. Take away the water by the same technique we said before in the formation of protein. I will take the hydroxyl group from the carboxylic group, and the water will be formed by taking hydrogen from the amino group and the hydroxyl from the carboxylic group. I will take away this water. So minus H2O. like any H2O, it's hydrogen and the hydroxide. Then remove this OH and remove this hydrogen and rewrite the structure again. I will remove this hydrogen and I will remove this hydroxyl. Rewrite the structure again. I will start writing from the left side. So here. Yalla, write with me. Box. Here is NH. And here is another NH. Then I will skip this part. Jump the road and write C double bond O. اللهم افتح علينا فتوح العارفين. You can see here, this is NH and C double bond O. This is the amide linkage. Then another C double bond O. Then leave this one is open. Now check with me. We have two different monomers. The first monomer is this one, which is, it was diamino. And the second monomer is this one. It was dicarboxylic. Now we have amide linkage. We still have amide linkage. But actually, this is not protein. This is nylon. Why nylon? Because if you check here, the left and the side, the right side of the monomer, you will see similar functional group. C double bond O, C double bond O, and NH here and NH here. It's totally different from this one. Remember, this one C double bond O NH and C double bond O NH. But this one, sandwich between two carboxylic and sandwich between two amino. That's why this one is nylon. It's not protein. Is that clear? Everything is clear up till now? I hope that everything is clear. طيب كده we can move to the polyester. Check with me to the polyester. Right here, polyester. We said that the polyester means ester linkage. In the ester linkage, we have C double bond OO. From where this C double bond OO comes? From the functional group containing carboxylic and functional group containing hydroxyl. If we talk about fats, which is the first polyester, we have monomer called fatty acid. The fatty acid is just a box like this, which is carbon and the hydrogen. I don't know, and I don't need their numbers. And we have two functional groups. One of them is carboxylic, and the second is all. So this is the general structure of the fatty acid. Acid يبقى carboxylic group. Then we have OH. Now, if you have two acids like this, one wants to join together. So this is fatty acid number 1. Okay? Fatty acid number 1, C double bond O, OH. This is fatty acid number 1. And this is the OH. And the fatty acid number 2. This is the OH. And this is the C double bond O, OH. Fatty acid number 1 and fatty acid number 2 wants to join together. The plan, like the first one, we will remove the water. We will take the OH from the carboxylic group, and we will take only the hydrogen from the hydroxyl group. Then, yalla, remove the water. Water will be taken away. We will remove the water. We don't need this water. Okay? And I will remove this hydroxyl group from the carboxylic and this hydrogen from this side. Then rewrite the structure again. I will write from here, fatty acid number 1, C double bond O. And here we have O. Then jump the road. Don't write the blue one. We will take the water away. Minus H2O. Then when you jump, you will see oxygen here. This oxygen, don't forget. Then fatty acid number 2. Then C double bond O. All what we are doing now is writing the equation for the polyester. Any polyester, PET, trilene, any polyester. It consisting of two monomers, diol or dicarboxylic. This question was in 2025, November, variant 3 and variant 2. PET والتريلين, they are polyesters. They consist of two monomers, dicarboxylic and diol. And this is the equation. This is the general equation for any polyester, synthetic polyester. Okay? You don't need to know the carbon and the hydrogen in this story. All what you need is to know that is ester linkage. Okay? طيب, this is polyester natural and this is the fats. What about the synthetic polyester? If this is the fats which has carboxylic group from one side, this is carboxylic, and you have hydroxyl group from the other side. The synthetic بقى dicarboxylic وdiol. So let me start draw with you the terylene or PET or any polyester. Here we have dicarboxylic and diol. C double bond O, OH. And here we have C double bond O, OH. This is the dicarboxylic. And this one, diol. OH and OH. Okay? Now what you are going to do is to remove the water. How can we take the water? Like every time, take the hydrogen from the hydroxyl and take the OH from the carboxylic. Then go ahead and remove this water. Then there is one hydrogen will be removed from this one and one carboxylic will be removed from this side. Rewrite the structure again. Now be careful, we have two monomers now. This is the dicarboxylic and this one is diol. Now rewrite the structure again. I will start from here. C double bond O, and here C double bond O. And you will jump the road, jump the bridge. You will see here oxygen. This is the ester linkage. Another box, O. Now don't forget that, this is a monomer and this is another monomer. This one is a monomer and this one is another monomer. Here. Polymerization process needs high temperature, high pressure, and a catalyst. Okay? But what happens if we are going to make hydrolysis for this ester? Hydrolysis of protein is cancelled from your curriculum, but hydrolysis of ester is in your work. If I'm going to make hydrolysis of any ester, all what you are going to do is return it back to its original state. Return it back to its original state. يعني you will give the carboxylic group its OH and you will give the hydroxyl group its hydrogen. Return back the hydrogen. Here we took the hydrogen. Return the hydrogen back. And return back the hydroxyl to the carboxylic. Here we took oxygen. هنرجعها لها. And this one we took hydroxyl. Give it back. So return it back and separate the two ions, the two molecules, the two monomers. So I will draw the first monomer here. Return back everything to its original state. فاحنا we take hydroxyl, I will return it back. I took here hydroxyl, I will return it back. And this one, it was OH and OH. So everything will return back to its original state. The monomer which we took from it, OH, I will return back the OH to this monomer. And the monomer that we took from it, hydrogen, I will return the hydrogen again. So now this is called hydrolysis. What's hydrolysis? Adding plus water. Adding water. You make hydrolysis by adding water. The hydrolysis is a chemical reaction in which you break down a large molecule into small molecules by adding water and catalyst. By the way, in the old curriculum of the Cambridge, you were having hydrolysis of protein. but hydrolysis of proteins is cancelled from your new curriculum, but you have hydrolysis of ester. When you break down any ester, you return back the ester to its original initial state. Any ester, it was having dicarboxylic with diol. Those are the dicarboxylic and the diol. It was having ester linkage. This one. But now we do not have ester linkage. After hydrolysis, we do not have ester linkage. Okay? At this part, guys, we can say that we end all polymerization. Of course, I will send you all the papers we wrote now. You can take break 3 minutes and back again to the mobile, drink some water, refresh your energy, and be ready for taking some equations and some definitions, okay? This is part 2 of the revision. Yalla, you have break 3 minutes. يلا يا شباب, bring your copybook and start with me your part 2 final revision, okay? I'm still writing now in the organic chemistry, as I know that in the organic chemistry, one of the heaviest topics in your curriculum. I know this. It's okay. I appreciate that you are trying. But once you are trying, it's okay to memorize and revise one more time. يعني don't study the organic chemistry once and you say, Alhamdulillah, I have finished. No. Organic chemistry, you have to study more than one time. Okay? طيب, let me revise with you now the part related to the equations of the alkanes and the alkenes. Okay? So here, I will write here equations of alkanes and alkenes. General equations of alkanes and alkenes. Let me start with alkanes. How alkanes react if we are talking about alkanes. Alkanes react by more than one way. They can react with oxygen, and this is called combustion. And actually, we have two types of combustion: complete combustion and incomplete combustion, right? Alkane can react with halogens, especially chlorine. And this reaction in chemistry called substitution. Alkane react by substitution. Alkenes don't react by substitution. Substitution reactions for alkane only. And alkane can react by cracking. So you can break down the long chain hydrocarbon into smaller one, and cracking has an economic importance. Why cracking has an economic importance? Because by cracking, we produce small and shorter chain alkene, small and shorter chain hydrocarbons, which is having high demand. They required more. They can be used as a feedstock and starting material for other industries. They can be used in making polymers and plastic. Okay, يبقى كده الالكانز react by three ways. They react by reacting with oxygen, and this is called combustion. React with chlorine, react by cracking. طب let's see the first part, combustion. A, combustion. How they react by combustion? We said we have complete combustion and incomplete combustion. For the complete combustion, the products of the complete combustion are carbon dioxide and water vapor. So if you have an alkane like ethane C2H6, you give it oxygen, 100% the product will be carbon dioxide and water vapor. If you need to balance this equation, you will count. How many carbon do we have here? 2. You must add here 2. How many hydrogen do we have here? 6. You must add here 3. To be 3 times 2 equals 6. How many oxygen do we have here? We have here 4. And how many oxygen do we have here? We have here 3. So the total number of oxygen here is 7. So to make this oxygen 7, you need to add 3.5. It's better to make this equation times 2. Cambridge usually prefer to make it whole number. So I will rewrite the equation after timing the equation by 2. It's going to be 2C2H6 plus 7O2. And this will be 4CO2. And this is going to be 6H2O. Try to balance again. Check that the balancing is correct. You have now 4 carbon. I have here 4 carbon. 4 times C. I have here 2 times 6, يعني 12 hydrogen. You have here 12 hydrogen. Type this one is 14 oxygen. So now you have here 4 times 2 equal 8. And this one 6 times 1 equals 6. So 8 and 6 total is 14 oxygen. Done. Clear? So this is the first one, which is complete combustion. Let's see the incomplete combustion. Number 2. What about the incomplete combustion of ethane? The incomplete combustion is just to give me a product of carbon monoxide and H2O. Here, the product will be carbon monoxide, not carbon dioxide. Okay, let's write the equation. We have here C2H6 plus O2, combustion, and it will give me CO plus H2O. Yalla balance. We need to balance. How many carbon here? 2. يبقى you need to add here 2. How many hydrogen here? 6. يبقى you need to add here 3. Okay. Now, how many oxygen here? 2. And how many oxygen here? 3. So the total number of oxygen will be 5. So this one gonna be 2.5. So times the equation by 2 to make it whole numbers, I will make it times 2. So 2C2H6 plus 5O2 will give you 4CO plus 6H2O. Did you observe that there is a big difference between the number of oxygen needed for complete combustion of 2 moles of ethane and the number of oxygen needed for making incomplete combustion for 2 moles of ethane? Did you observe this? So the incomplete combustion in which there is inadequate, the word inadequate means limited amount of oxygen. When there is limited amount of oxygen, the combustion will be incomplete and the product will be carbon monoxide and water vapor. This is the combustion of alkane. But what about the substitution reaction? Be careful because the students usually mix between substitution and addition. If this is ethane, CC, and we have hydrogen, 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 and there is hydrogen, 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 and you just add Cl2. Now what happened is in the presence of ultraviolet, ultraviolet is the condition for this reaction. One of the hydrogen of the ethane will be displaced by chlorine. هو ده chlorine. Cl bonded لCl. So we have chlorine and chlorine. One of them will displace one of the hydrogen. Ethane, open the door, give me one hydrogen, and I will give you one chlorine. Substitution. Displacement. One atom displaces another atom in the organic or hydrocarbon structure. So now the structure will be like this, CC. And we have 3 hydrogen the same. And here the 3 hydrogen will be only 2, and one of them will be chlorine. Did you observe that one hydrogen is displaced by chlorine? So now what is the name of this product? It's chloroethane. So what is the name of the second product is formed? This is HCl. Because this hydrogen, when it comes out, it will combine with this chlorine to make HCl. Okay, so now this reaction is called substitution. If you want to write it again by the molecular formula, it's C2H6. When we give it Cl2 in the presence of ultraviolet, it will be C2H5. 5 بقى. We displace one hydrogen plus HCl. Okay, and this is Cl. So it's going to be C2H5 Cl plus HCl. The same happen for any alkane. Okay? Then the third reaction for the alkane is cracking. In cracking, we break down the long chain hydrocarbon into shorter chain hydrocarbon. So this structure is long, and we don't need this long structure. We need a short structure which is economically more useful and has a lot of uses. طيب, how can we make cracking? We can have a structure like octane. It's C8. C8 in cracking بقى. H, remember, CN, H to N plus 2. يبقى it's not 16, it's 18. 8 times 2, 16 plus 2, 18. We will make cracking. We need to make this cracking just to produce C2H4, which is ethene. So what is the remaining hydrocarbon? Subtract. ال8 minus ال2 يبقى C6. وال18 minus ال4 it will be H14. So now the product is ethene and hexane. Imagine. So in this kind of cracking, you produce alkene plus alkane. So the same one, C8H18, can be cracked. Imagine to be C8H16, which is octene plus hydrogen. So cracking is one method to prepare alkene from its corresponding alkane. This is octane and this is octene. يبقى you can change octane into octene by cracking. This is one method for preparing the alkene, by the way, is to make cracking for the alkane. Fine. طب what about بقى the reaction of alkenes? To make the reaction of the alkenes can react by addition and by combustion, like alkane. I will not repeat. Combustion and addition. This is the one I will focus today. And the polymerization, and I will not repeat polymerization. We said it at the beginning of the session. So I will focus on this one, addition. How they react by addition? They are reacting with hydrogen, and the reaction is called hydrogenation of alkene. Hydrogenation. And they react with steam, H2O gas, and this reaction is called hydration of alkene. And they react with what? Bromine. This is the test of unsaturation. They react with bromine, and this is called test of unsaturation. Okay? Here is the part of the hydrogenation reaction with hydrogen. 1, 2, 3. C. Reaction number 1. If you have alkene like C2H4, and I will give it hydrogen, what happened is this reaction needs nickel as a catalyst and temperature 150 Celsius. The double bond will be broken and the hydrogen will added to the two bonds. مش هو الإيثين C double bond C, and we have hydrogen, 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 hydrogen. So what you are going to do now is to break down this bond to change it into C single bond C. Okay? When you break down the bond to be C single bond C, and you still have the 4 hydrogen, you will add, don't displace, don't substitute. You will add these 2 hydrogen. 1 hydrogen here and 1 hydrogen here. يعني it will be C2H6. No more products. It's only one product is formed. That's why this is an addition reaction. This reaction is called the hydrogenation of alkene. Hydrogenation of ethene produce ethane. What is the difference between any alkene and its corresponding alkane? 2 hydrogen. الالكين CnH2n, الالكان CnH2n plus 2. So here is ethene and here is ethane. Okay? And this one is hydrogenation of alkene. You change the propene into propane, butene into butane, hexene into hexane, and so on. Clear? طيب, let's move now to the second reaction, which is hydration of ethene. If you have another ethene, C double bond C, and the hydrogen, 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 hydrogen. This time I will give it H2O, which is steam. At very high temperature, the double bond will be broken. The 4 hydrogen stay the same, but you add the OH and the H. ما هي water, any water in chemistry is hydrogen and the hydroxide. When you add this OH and H, so now you change this alkene into alcohol. So hydration of ethene producing alcohol. So instead of having C2H4, now you're having C2H5OH. This is ethanol. We call it what? Ethanol. So the ethene change into ethanol by hydration. Conditions of this reaction is 300 to 500 Celsius. And the catalyst phosphoric acid H3PO4. And you need pressure from 60 to 70 atm, atmospheric pressure. Difficult reaction, needs a lot of energy and very expensive. Finally, the test of the unsaturation or the reaction of the alkene with bromine. This is a spontaneous reaction without any conditions. All what you need is to have the alkene C double bond C. It will not be written here. Mesh. Let me write it here above. All what you need is just to write the C double bond C, hydrogen, hydrogen, and you will add the bromine, Br2, and the product will be C, double single bond, the C, and you will add directly the Br. 1 with 2 dibromoethene. 1 with 2 dibromoethene, because this ethene can decolorize bromine water. Decolorize bromine water. Actually, the bromine water is orange. And when we add the ethene, the color of the bromine water itself change from orange to colorless. يعني مش الايثين هو اللي بيتشينج to colorless، هو كده ولا كده الايثين is colorless. The bromine water is decolorized. Decolorized means its color change into colorless. Okay, we call this the test of unsaturation. This is the test of unsaturation. Bromine water is decolorized. The bromine water is decolorized. That's it, okay? This is all the reactions of the alkanes and the alkenes, and this is all the polymerization. So now you have the reactions and the polymerization in 10 pages. I will send it to you now. Please read them again and try to rewrite them again. Equations and writing the equations are very important in this part. If you didn't write the equation, you will not remember, okay? يلا هتقول معايا: اللهم إني أستودعك ما قرأت وما حفظت فرده إلي عند حاجتي إليه إنك على ما تشاء قدير. صلى الله على سيدنا محمد صلى الله عليه وسلم. Thank you guys for your nice class as usual. See you inshallah the next session. Okay? Love you more والله. Love you more and more. See you inshallah the next session revising another part. السلام عليكم. Have a nice evening. Bye.